All right, it's 8:01. And without further ado, let's go ahead and get our Think Data Thursday started. So welcome to Think Data Thursday. My name is Patrick Byrne. I'm a Customer Solutions Program Manager at Tableau. I help maintain and moderate our community forums. And on the call today, we also have Senior Customer Solutions Program Manager who just started with us, Stephen Munoz, as well as Customer Solutions Program Manager Kiara Brennan, and our Community Manager, Amanda Boyle. Who will be fielding questions in the chat and the Q&A as we go through this that are pertaining to some of the administrative functions outside of this. So today we have two-time Tableau Zen Master Ken Florage presenting an introduction to data densification. Ken works at Bucknell University as a business intelligence architect, where he is responsible for architecture, design, and development of data warehousing and analytics solutions across all functional areas of the university. Ken began using Tableau in June 2016 and fell in love with the platform immediately. And of course, now he is a phenomenal Zen master. And with that, I'm going to hand it off to Ken.
All right, thank you, Patrick, and the rest of the Tableau team. So as Patrick mentioned, I'm going to take you through an introduction of data densification. This is a somewhat esoteric kind of concept. And I know for me, when I first encountered people doing it to do things like draw curves, that it just seemed like magic to me. And it took me a while to kind of get my head around it. So what I hope that I'll be able to do here by getting sort of hands-on with it and showing you some techniques on how exactly to do it, excuse me, hopefully I can help this sort of demystify this topic a little bit. So specifically what I'm going to do is take a specific use case, which is drawing curves in Tableau, and I'm going to show you a couple of different techniques for using data densification to do that, and sort of try to explain why we need to use data densification for things like this. And at the end, I'll give you some other examples of where I've used data densification in my own work, maybe not necessarily specifically for curves, but for some other potential use cases. So hopefully you can take that and get some sort of idea of how you can apply this to your own work. So before I jump in, it's probably good for me to at least attempt to give somewhat of a definition of data densification. And I think there could probably be a very good community discussion about what it is and what it's not and those kinds of things. And I don't want to get into that. I'll save that for later. To me, and part of the problem is data densification is very closely related to things like data scaffolding. You know, I would personally sort of call data densification a type of data scaffolding, but I think others might say the opposite. But for me, and for what I'm showing you here today, data densification is really just sort of a technique by which we introduce additional records, or sort of artificially create these records in our data in order to draw something more complex. And that's a super simple and super vague definition. But I'm just going to kind of leave it at that, and we can have a community discussion offline about the ins and outs of that. And at the end, I'll also give you some additional resources for reading on some of these other topics. So let's just jump right in again. So the main use case here I want is for us to draw a curve with data densification. So what I'm going to start out with is this very simple little data set that has two records. I've got point A and point B. I've got X and Y coordinates for each of these points. And what I want to do, my goal, and so I've plotted them here on a simple little scatter plot in Tableau. And so my goal is to connect the dots. Now, ultimately, my goal is going to be to connect them with a nice smooth curve. But just so that we can sort of dip our toes in the water and get started slowly, we're gonna connect these with a line first, and then jump into curves. So connecting dots with a line in Tableau is super simple, right? We have this line mark type, so we can just use a line mark type and it just connects them directly. And Tableau is able to draw straight lines between points, so we don't really need to do anything extra with data densification in order to draw those lines. I'll just note here that I've got dual axis so that I can do both the line and the individual points so that you can see those each separately. But even though we don't need data densification to draw a line, I'm going to show you how to use densification to draw a line as sort of a basic first step. All right, so for starters, we're going to just draw 5 points. And what we kind of want to do is have those 5 points sort of evenly spaced across this line here. So specifically, I want to focus on spacing them out evenly across my x-axis. So if I have 5 points and I want them evenly spaced across, my first is going to be at 0, my next is going to be 0.25, then 0.5, then 0.75, and then 1, right? So basically there's a spacing of 0.25 in between each of those points. But the first thing is I've got to somehow sort of artificially create these points. So the first technique I'm going to show is sort of pre-densifying or pre-configuring these values outside of Tableau. So if I switch over to my data set, I've created a new tab in my spreadsheet here, which has a single column called extra point, and it has 5 records numbered 1, 2, 3, 4, 5. Those are going to produce those extra points in my data set. So I'm going to create a new data source, and I'll show you how to put this together. Connect to my data. Here's my data, which has my 2 points, as I showed you before. And I'm going to bring in my pre-densified 5-point data. So we have to join these two together. And what we want to do is use a cross join. And a cross join is, this is a database term. A cross join allows you to take every record in one table and join them to each of the records in another table. So in this case, I've got 2 records in data, 5 records in pre-densified, and so that's going to create 10 records. Tableau does not have a built-in cross join, so we have to sort of trick it using join calculations. So essentially what we're going to do is create a join calculation on the left, give it a value of 1, create a join calculation on the right, give it a value of 1, and because 1 is always equal to 1, we're going to get that cross join sort of effect. These values don't have to be 1; they could be, just the word join if you like. Do that. And that will give us the same effect. Key is that both of those values match on either side to create that cross join effect. Okay, so let's come back to our dots. So the next thing we want to do is create some calculated fields to figure out where to place those dots. So one of the things we're going to need for this, and so I've kind of built up a couple of calculations that we'll use to build larger calculations. So first calculation is just figuring out the number of points in our data set. So I'm just using an LOD to grab the max of extra point. So that will give me this 5. One thing I just want to note real quick is in certain areas in this presentation, I'm probably going to sort of quickly gloss over a calculation, or something may look a little bit weird on screen because I'm doing something just for presentation value. So if I do that and I lose you somewhere along the way, please don't hesitate to ask a question through the Q&A, or you can reach out to me afterwards, and I'm happy to dive into a little bit more detail. So anyway, max densification points is going to give us our number of points. In this case, it's 5. Now, I could have just hard-coded this to say 5. But what I want to do is reuse this calculation as we move forward, and we're going to increase that number of points slowly. So I want this to be able to automatically calculate the maximum points, so I don't have to go in and change that every time. So we're just going to automatically calculate that with this. Next is we want to figure out that spacing. So I told you before that the spacing is 0.25. So this calculated field will give us that. So basically, it's 1 divided by the max densification points minus 1. So our max densification points is 5, minus 1 is 4, 1 divided by 4 is 0.25, right? From here, we then want to figure out how to place our x, or sort of evenly space those points across our x coordinate, or our x axis. So that's where this densification straight line, again, this is focused on building the straight line here in this case. So the formula for this is our extra point number minus 1 times the spacing. So point number 1 is going to be 1 minus 1, which is 0, times spacing. That'll give us an x coordinate of 0. Point number 2 is 2 minus 1. 1 times 0.25 will give us a coordinate of 0.25 and so on, until we get to 0.5, 5 minus 4, 5 minus 1 is 4, 4 times the spacing is 1, and that'll give us this last point. All right. So the next key thing, I want to point out is that when we're drawing lines or drawing curves or any of these sort of shapes in Tableau, they're all defined by a mathematical equation. So if I take you back to high school math class, I think we all remember drawing lines on a Cartesian plane, plotting the x and y coordinates, figuring out the formula of those lines. Generally, straight lines are put in a slope-intercept form, which is a type of equation, and those would generally express the value of y in terms of x. So y is expressed as a function of the value of x. So if you can figure out x, you can figure out the value of y. And in this case, our straight line is very simple. It's our y value, even though it's sort of wide on screen, our y value is actually the same as our x value. So the equation is pretty simple. It's y equals x in this case. Now, when we get to curves, the equations will get a little bit more complicated, but the same basic concepts apply. So to figure out our y coordinate, because y equals x, the value of y is just going to be the same. We can just set it to the value of our x coordinate like this. All right. So that gives us, calculates all of our points, and then when we plot those on our scatter plot, we get something like this. So we can see our points at the right places: 0.25, 0.5, 0.75, and 1. So we've just used data densification to draw a straight line. Now, this is a totally sort of pointless exercise because we don't need these extra points to connect with a straight line, right? It's kind of a useless exercise, but I just wanted to use it as kind of a quick example and an easy to understand example of how we use data densification. Curves, of course, are a little bit more complicated, right? So Tableau out of the box will allow you to connect points with a straight line. They will not allow you to connect points with any sort of type of curve, right? So in order to draw the curve, what we're going to have to do is figure out all these individual points and then connect them in this way. Now, the one thing I want to note here is that when you draw curves in Tableau, or really any sort of computer technology that might be available, the computer really isn't drawing curves, true curves at all. Really what's happening is we're plotting a bunch of points along that curve and then connecting them with straight lines. Now, if we create enough of those points and they're close enough together, our eyes can't really tell that that's not a smooth curve. But ultimately, under the covers, it's just a bunch of straight lines, and they're so small that it looks like a nice smooth curve. So we're sort of tricking the computer into drawing what looks like a curve. Okay, so to do this, we need to leverage the formula for a particular type of curve. So I'm going to use a sigmoid curve, and sigmoid curves are used in Tableau quite a bit. You'll see them in curvy bump charts and sinkies and curvy slope charts and different things like that. They're not always the best type of curve. Jeffrey Schaefer just wrote a great blog, and Chris DiMartini wrote a great blog where they talked about the use of sigmoid curves and sinkies and kind of came to the conclusion that there might be better options for that. But since sigmoids are used pretty frequently and it's a somewhat easy type of curve, we're going to use that. And as I said before, curves are expressed in a mathematical formula just like a line. The formula is maybe a little bit more complex than a line, as you can see here, but ultimately, here's our formula for a sigmoid, and as I said, as with the line, y is expressed as a function of x in this case. Don't worry too much about the math on this. Someone else figured it out. I don't really understand it. I'm just able to just kind of leverage it and use it within Tableau. So we're going to need to create some slightly different calculated fields for this. Now, we're going to start with our x coordinate because we want to figure out that x coordinate first before we figure out the y. I won't go into a ton of detail on this, but with a sigmoid curve, in order to get a nice smooth curve, you generally want to plot your x coordinates starting at -6 and going to +6. and you can fill them in from there. So this formula is basically just taking our x coordinate and figuring out how to evenly space them between -6 and 6. And then our y is just a expression of the formula I just showed you. So we can see 1 divided by 1 plus exponent sigmoid x whatever, right? Again, I don't understand all that, but I'm able to just sort of turn that formula into a calculated field within Tableau. So now, if we plot this, we get a curve. It doesn't really look much like a curve though, right? And this is because of what I said before. Tableau, we're not drawing true curves. We're plotting points along a curve and then connecting them with straight lines. And because we only have 5 points in our data set, this ends up just looking really blocky. It looks like basically 3 straight lines, right? And so that's sort of a good indication to us that we need more points in our data set in order to really draw a smoother curve. So let me come back to my data set. And I created a new one that has 12 points. So let's see what happens when we use 12 points. Now, all the functions, all the calculated fields are the same because we automated the max densification points and the spacing. We don't have to do anything to adjust our calculated fields. We just have to update our data set. So here's what it looks like if we have 12 points. So it starts to look a little bit better, starting to look a little bit more like a curve, but still very blocky. You can still definitely tell that there's some straight lines there. For certain use cases, this might be good enough. But if you really want a straight curve, you're going to really need to increase that number of points. So let's take our data set and we'll create 50 points. Once again, no changes to the calculated fields or anything like that. We just update our data set to this new data set and we get something like this, which looks a lot smoother. And let me take away the dots just so we can kind of prove that, right? So a sigmoid curve, what people have found is that around 50 points or so tends to give you a pretty nice smooth curve. And our eyes really can't detect those individual little line segments. It just looks nice and smooth. Now, depending on the curve, depending on the size of the curve on your screen and lots of other aspects, you may need more or less points in your data densification. For example, I use this technique to draw circles a lot. And I find that 50 still kind of looks a little bit blocky on a circle, depending on how big it is on screen. So I'll tend to use maybe 100 just to be safe on that. So it all depends on the curve, and you can kind of play around with that and find what works best. So this is the first method. I refer to this as the pre-densified or pre-configured values for doing data densification. Now, one of the problems with this, and I'll get into this in a little bit more detail at the end, but one of the problems with this is because we had to do that cross join, we took our 2 records, these 2-point records that we're trying to connect, cross joined them to 50 extra points, and our data set exploded from 2 records to 100 records. And that's not a big deal when I've got 100 records. That's not a big data set. But if I'm dealing with thousands or tens of thousands or millions of records, that explosion of the size of our data could potentially cause us some problems. So another method for densification is to leverage bins. All right, so this gets a little bit more complicated because we're dealing with table calculations and bins and things like that. But I'll try to walk you through, and I think you'll find that it's not overly complex. So we're going to start out with another data set here. So we're going to just draw 5 points again from the beginning, and then we'll increase it gradually. So our data set here is just going to be a single column like we had before, called it range. And this is going to range from values 1 to 5. So let's create a new data source again, connect to my data. I'll bring in my point data, and then I'll bring in my bins data here. Once again, we're going to do a cross join using a join calculation, and we get our data. So a key point here is even though we're densifying this 5 times, because of the way we're setting this up and how we're going to leverage bins, we're only going to produce 4 records. And even if the range went from 1 to 1,000, it's still only going to be 4 records. So that's one potential value in this approach. All right, so the first thing we want to do is create bins on this range field. I'm going to do create bins, and we'll do a bin size of 1, like this. All right, so one thing we always want to do when we're using bins for data densification, and I'll give credit to Chris DiMartini for teaching me this trick. If you drag this up to rows, sometimes I find, and I'm not sure what causes this, but sometimes I'll find that the bin will only show the first and last value. You want to make sure that you put this up on rows or columns and you ensure that show missing values is selected. When you do that, it should always create those in-between values on your bins field. So as just a matter of practice, make sure you always do that. Check that show missing values is shown, or else you can get some, you'll really end up dealing with some headaches by doing that. So once we do this, let's drag this down to detail, and now we'll get these sort of 2 dots. Now we want to create we want to artificially, so remember in our pre-densified, we had this extra point field. An extra point was used in our calculated fields. I'd like to keep leveraging all those calculated fields if possible. So what I want to do is create an extra point value that gives me 1, 2, 3, 4, and 5. And for that, we'll use an index field. So when we create a calculated field, I'll call this extra point. I'm adamant about adding comments, so I'm going to throw a comment in there. I'll use index, create points 1, 2, 3, 4, etc. And then the formula is just our index formula. All right, so I'm going to drag extra point up to detail here, and it won't change anything. What's important is that we make sure that we compute this using range bin. So when we do this, we'll see that it will explode up to 5 points. Increase the size, we'll label this here, square. So you can see here now I have extra point 1, extra point 2, extra point 3, 4, and 5. So essentially I've used bins to sort of artificially create those extra point values that I created manually within the other data set. Okay, so let me switch over to a data set where I've already kind of created all the calculated fields. So we have our bins, and then we have some additional calculated fields. So we do need to make one quick modification to max densification points. And I realized as I was doing a run through of this earlier that I've overcomplicated this formula. This really could just be like this. So basically, because we're using table calculation, it gets a little hairy with sort of making sure these values are available to all those different table calculations. We want to take the max of the range and then do a window max of that. I won't go into a lot of detail on that, but this will give us that number 5 in this case. X spacing will remain the same formula. Densification straight X, densification straight Y, those are going to be the exact same formulas as we used before. So when we plot these, we'll get pretty much the same exact thing as we did when we did our straight line densification. Another thing I want to point out is that since we're leveraging index to create that extra point field, everything that uses that from there on out is going to be a table calculation. And we can see the little triangle next to each of these pills. So we need to make sure that each and every one of these is set to compute using range bin. And if we're going to display the point value, for example, we need to do that as well. We can see points 1, 2, 3, 4, and 5 all in the right spot. Once again, because we've done the underlying basic calculations, the calculations for X and Y for the sigmoid curve aren't going to change. They're basically the same as they were before. So when we draw a curve with 5 points, we see this blocky sort of curve like we saw before. All right, so to increase the number of points using bins is a pretty simple process. So instead of having a range from 1 to 5, we can change that range to go, say, from 1 to 50. And everything else will be the same. All the calculations are automatic, so that will work. The one really nice advantage is that we still have only the 4 records as we had before. So instead of the 100 records we had with the first method, we only have 4 records here. So now when we plot them, we can see our nice smooth curve here. Again, we want to make sure all these things are computing using range bin. And if we take away the points, we can see that nice smooth curve here. All right, so that's the two basic methods for doing data densification. So the third one I want to show is sort of just a slightly different method from the bins method that I showed. But I want to talk briefly about some of the pros and cons. Other people will probably know more about when to use these or when one is better than the other than me. Folks like Jonathan Drummey, who helped to sort of innovate a lot of these techniques, could probably give a lot better explanation of this to me. But from my standpoint, I think one of the advantages of the bins method is it does reduce the amount of data that you're dealing with. So in the case of 50 extra points, we went from 100 records to just the 4 records. So if you do have a lot of data, then that might work a little bit better. On the flip side, you're introducing table calculations when you use the bins method, and Tableau has to work a little bit harder when you're using table calculations. So I'm not sure if you're really going to get the bang for the buck ultimately by doing the bins method because of that extra complexity that you're adding to it. So it probably depends on a lot of other factors, which method you use. I admittedly tend to use the pre-densified method because anytime I can avoid table calculations, I do. I think it just makes everything simpler and it makes Tableau not have to work quite as hard. But there are times where it makes a lot of sense to use a bins method. And this third method I'm going to show you is one of those times where it absolutely is sort of required. So I've encountered a couple of use cases where I wanted it to be sort of the number of points to be configurable at runtime. To where I can create what I want and then maybe fiddle with that number and say, 40 points is enough for what I've created here, or maybe I need 80, or maybe only 10 is what I need. So if I can sort of configure that at runtime, I can figure out what works best. Or sometimes maybe I want to present that option to the user and let them configure it. And I'll give a sort of a strange example of that that I've created here at the end. So this method I call the configurable bins method. The idea is we wanted to be able to just sort of automatically, or not automatically, but be able to adjust that top number as we see fit. All right, so to do that, I'm going to create another data set here, and I'm just going to have range just like the bins method, but I'm just going to set it to 1 and 2. All right, so let's connect and create that data set again, just like we did before. Drag data over, drag bins configurable, do our cross join. And there's our 4 records. All right, so I don't want to create bins on range here because that's just going to give me the 2 values, 1 and 2. What I want to do is first create a parameter here. So I'm going to create this parameter. I've already created it called number of points. I'm going to range it from 2 to 100. Obviously, we don't want a value of 1 in the number of points because you can't draw any sort of line or curve with just 1 point. For now, I'm just going to set this current value to 5, and then let's show this parameter on screen. So now I'm going to create a calculated field, and I'm going to call it range adjusted. And we'll adjust our range based on number of points. All right, so we're just going to do a simple if statement. If range equals 1, then we just want to return the value of 1. Otherwise, we want to return number of points. So basically, if it's 1, we'll start out as 1. So our starting range is always going to be 1. If it's 2, then we're just going to use the number of points. So in this case, this range adjusted is going to range from from 1 to 5. Now we're going to create bins on this one instead of the regular range field. Create bins, size of bins 1. Once again, we'll drag it up, make sure show missing values is selected. It is, so we're good. And we can see we get those values 1 to 5. Now, as I fiddle with this number of points, you can see that grows. So this creates that sort of configurability within our bins field by doing this. Go back down to 5 or something close to 5. All right. So from here, if I switch over to the one I've already done, there are a couple modifications we need to make with this. Certainly, any table calculations that we're using, we need to make sure are now computed using range-adjusted bins instead of range bins. Max densification is going to be a little bit different. We don't need the, well, that's a bad comment. We can get rid of that. But basically, because it's always going to be this value, we can just set it to the number of points, and that's super simple, easier than before. But from there, X spacing, data densification, straight X, sigmoid, straight X and Y, those are all going to be the exact same formulas. And then we can plot this, and now we see our sorry, I went back. We can see our curve, in this case, has 6 points, but I can increase these as I like, go up to 50, go up to 100 if I like, and I can see, you know, this curve build. So if we take away the dots, I'll point out something here, is that with 22 points, you can still see a bit of blockiness in the curve. You can see some of those sort of straight lines like right here. And you know, once you get up to that 50, and as you go sort of past 50, we don't really see much difference here. So that was what I said before, and sort of confirmation that at least for a sigmoid curve and for similar curves like sine curves, that 50 mark is pretty much a good target. So you might be looking at this and saying, you know, why would I want to use this method, or what value is there? So I think there are a couple of different scenarios. It is sort of a niche scenario that you probably are not going to use a lot, but I'll give you one sort of weird example of where I leverage this configurable bins technique, and that's these shape-shifting maps. So last year there was a spate of new innovation around hex maps and tile maps. And so Roddy Zakovich had created a polygon version that eliminated the need for custom shapes and the difficulty of sometimes sizing those on a dashboard. And then there was some additional innovation. So I had this idea. I wanted to be able to create any type of shape on a tile map like this. So what I did was I basically created formulas that would draw circles. So here we've got 100 points, and as I draw a circle with 100 points, I get a nice smooth circle. But a circle with 4 points is just a square. It's just evenly spaced points around the circle connected with straight line. A circle with 8 points is an octagon. So I'm kind of leveraging and sort of tricking Tableau into drawing these what are called regular polygons by using a circle shape. And so now with this, if I want a circle map, I can fiddle around with my padding. So we'll do 0.8, and now we have a nice little circle map. Or if I want a square map, I can change my points to 4. Where's my square? So I got to look up my settings here. So horizontal padding, 0.45, 0.45, and rotation is 45. So now we have a nice square map. Or another option for 4 points is a diamond map. So let's rotate that. 0 degrees, 1.05, 0.1, and now we have a diamond map. All right, so this is a weird kind of example for using this technique, but it's just an example of sometimes you may want to allow the user to, at runtime, sort of configure the number of points so that you can do weird and interesting things like this. All right, so that's it for kind of the tutorial. What I want to do now is to show you a few examples of where data densification is used and show you how it's used in those. Anything that draws curves in Tableau, because you can't connect points with curves, and pretty much anything that uses curves is going to leverage a data densification technique. So a very common thing is a Sankey chart. So this is a multi-level Sankey chart. And so each of these flows is basically drawing a curve. And then it's not just drawing a single line, it's turning these into polygons. But it's basically using those data densification techniques to draw these curves in this sort of way. But it's not only for curves. Before I jump to that, here's another curvy example. So I just did this Fleetwood Mac visualization for Tableau's Data Plus Music campaign. And so each of these rings on this circle is a member or former member of the band. And so it's basically sort of a circular timeline. And this once again uses data densification to draw these circular curves. But as I was just about to say, it's not only for curves, there are other use cases. So an example is doing sort of this gradient coloring on area and bar chart. So Tableau does not allow you to color bar charts and area charts in this gradient fashion. So what I did to be able to create this is basically just break these bar charts into all these individual segments using bins, and colored each according to a range of this color palette. So even though at the surface it looks like it's just one solid bar that's colored in the gradient color, it's really just a stacked bar with slightly different colors. Same with the area chart, it's just a bunch of sort of stacked lines that create this gradient look and feel within the area chart. And one last sort of more fun example. Give me a minute. Is this example here where I've drawn a circle here, and I've drawn this circle with using data densification. So I've got 100 points. So that gives me a nice smooth circle. And I'll draw another circle and then another circle, and then I'm just going to kind of let it start drawing circles. Each of these circles, basically my data set is really just the center point of these circles and the size. And I've used data densification with 100 points to draw the outside and sort of fill these in as a polygon. And then I'm just sort of overlaying them on top of each other. And if I delay long enough, hopefully you'll start to see something that looks familiar. I'm going to take a moment to get a drink here. All right, so let me speed this up a bit. All right, so it started small and up in the corner of the screen there, but we've basically, used data densification to draw a bunch of circles, overlay on top of each other, and we've been able to create this sort of bubble art of Starry Night. So I leveraged a tool called Geometrize that's available on the web that turns images into geometric shapes. And again, just leveraging these data densification techniques was able to create this within Tableau. All right, so that's pretty much all I have for the tutorial. A couple of things that, sort of for further reading and to get a better understanding of some of these concepts. This technique is on my blog. It's called An Introduction to Data Densification. It goes through pretty much what we've just done, but you can see it. You can see it a little bit more closely. You can download the workbooks and explore it a little bit further if you like from there. In addition, there was a great presentation at PC Europe just last week by Klaus Schulte and Ludovic Tavernier. And they talked about some of the visits that they've created, and they definitely get into some detail about data densification and show some really good examples of where they've used that in their work. And one more thing that I'd like to plug is Jonathan Drummey. So as I mentioned him before, he's one of the innovators of these techniques that I think we all have learned from. He is in the process of preparing a presentation that he's hoping to give at the Tableau conference this year. And he's going to be doing a preview at the Boston Tableau User Group in August. And this is going to be sort of a grand unified theory of imputation, scaffolding, and data densification. So He's going to break down topics like data densification that I've discussed today, but also going to get into these other topics such as data scaffolding and bring them all together into this sort of singular presentation. So if you get a chance to see this either in Boston or anywhere else, then it's definitely one of those that you do not want to miss, because you're going to learn a lot about these really advanced techniques from, the master, Jonathan Drummey. So with that, that's all I have for you today, and we certainly have time for questions if there are any. And if there aren't any questions, or you don't feel comfortable asking them in this environment, then you can feel free to reach out to me. You can contact me through my website or on Twitter or a variety of other methods. So thank you, and we can take some questions.
Awesome. Thank you, Ken. Yeah, so we already have a couple questions in here. One is, if I have to viz warehouse activities, which chart comes to your mind? I was thinking of parallelment. I may have butchered that. I'm not so familiar with this chart type.
A parliament chart?
Yes, yes.
Okay. Yeah, I mean, so questions like that, it always depends. It depends on what the data is. It depends on what your goal is. It depends on, who your audience is, right? And so those are the questions that I would ask first, is make sure that you understand, the data and the goal and the audience and what story you're kind of trying to tell in that data before you pick a chart type. And one of the beauties of Tableau is that you can pull your data in and you can experiment with it. You can try different chart types. You can then go show those chart types to some of your constituents as a sort of a proof of concept, and you can kind of hone it from there. So just make sure that it's the use cases and the users that are driving those chart choices, as opposed to just trying to do something that is cool. Would a parliament chart make sense for a warehouse? I don't know. My guess is probably not, but again, it all depends on what your use cases are and the story you're trying to tell.
Awesome. We have another question here from an anonymous user. I appreciate your explanation using bins and pre-densified methods / using the parameter. But how does this help in real time? Like, how does data densification work for business dashboards? Do you have any examples you can provide?
Well, so I think once again, it all comes down to what do you need to build to answer the questions that are at hand. So if I think we go back to the Sankey, Sankeys have been somewhat maligned, and I think to some degree it's fair because there is a lot of misusage of Sankeys. But I've seen a number of really, really fantastic business use cases for Sankeys. And I'll give one example from my work. So I work at Bucknell University, and one thing we use Sankeys for is a lot of sort of student transitional kind of things. So a good example is we look at our students and what degree they graduated with, and then we look at what industries they're working in. So we can take a look at our engineers and say, are they working in fields in engineering? Are they doing things in education or something different than that, right? So it gives us a really good, clear picture of the flow of those students. And I've heard other great use cases like major changes and things like that. And even the warehouse example might be a good example if for a Sankey, where you might want to show the flow of goods through a warehouse. So I think Sankeys can be a really good and appropriate use case. And again, if you really want to be able to do that, you really need to use data densification technique. So again, it all comes back to your data, your use case, your users, and the story that you're trying to tell. But there are definitely cases where something like a Sankey or a jump plot or things like that can be a really, really good business use case.
Awesome. We do have another question. Any plans to have a session on data validation before you bring it into Tableau? Basically,
sorry, question again?
So basically, they're asking how how do you do data validation before you bring some of your data into Tableau? Have you ever done a session on that, or do you have plans to do one on that subject?
I have not, and you know, that's a big topic, right? And you know, it's certainly something I do a lot in my own work. A lot of my work is focused on sort of the data plumbing, if you will, and kind of cleansing data and rearranging it into a format that makes it easy for end users to consume. But it certainly is a big topic, and you know, certainly more than we can address here. But I think if you look around online, if you look at some of the videos from the past Tableau conferences, as well as you know, the Europe conference, I'm sure there are probably some good sessions on that. And of course, with Tableau Prep out now, that gives you a lot of opportunity to do that cleansing. Data validation is, I guess, a little bit different, right? Because you need to kind of really dig into that data, and you need to have subject matter experts that are there to help kind of make sure that data is clean. But I think you can find some good resources if you look around.
Awesome. And I don't have any more questions in our chat or Q&A. Kind of final call for questions from anybody if you want to shoot them over real quick. Not seeing any fly in here, so thank you so much, Ken. This has been amazing. I definitely was dropping my own jaw in the room here a couple of times as you went through this presentation. Just some housekeeping items for everybody. We will have this posted onto the YouTube playlist later today or early tomorrow, so feel free to check that out and share it out to any of your friends who might not have been able to attend this morning. And stay tuned for our next Think Data Thursday, which will be coming up next month, and we'll be posting some info about that very soon. And thanks again, Ken.
All right, thanks for having me.
Excellent. All right, have a good morning, everybody.